Hello, in this demo we're going to have a look at a simple particle system that's been written in Android. Have a bit of explore in terms of the classes, but we'll start off first of all just by running it to see what exactly it is we're going to get out of this particular particle setup. Now, if you haven't really done so, do listen to the, if you like, the introductory lecture that goes along with this, because it'll talk a little bit about particle systems in general, how they're structured, and this sort of builds on top of it in terms of looking at one specific implementation. So by running particle system demo, now as I sort of click in different locations, in this case here we're showing sort of an explosive effect where we are generating a number of particles which sort of go out from the center point and sort of slow down, fade out, and then sort of disappear. And depending wherever I click, this is where the particle will be centered on. So again, we'll have a look at how we can manage that. Other setup we have is going to be just an ordinary emitter, where wherever I click on the screen, we will have then a number of particles emerging from that point. And if I click at the top, you can see they fall down and they sort of fade out as they go down. All the particles are affected by a gravitational force pulling them down, but they're sort of going up or out in slightly different angles. If I were to drag around the screen like this, you can see then that depending upon wherever the mouse is moving, you sort of get the particles created in a straight line between them. So we're going to have a little look at how we create it so that, in this case, this is continuous, as opposed to the explosion, which was a burst creation mode. Here we have a continuous creation of particles being created out. So the last one we want to do, move down here. Well, actually, as I click, you can sort of see it moves around, and you can actually see there the particles moving up and fading away as they are created. This one's a smoke effect. So when I created the bottom, we have smoke particles being created as we go through this. So there we have notionally a billowing cloud of smoke. Particles created at the bottom going up, rotating a little bit, expanding, and giving you an okay smoke effect. You can get a better one than the one that's displayed here. There are three different effects, all produced by the same chunk of code. So we want to have a look at that chunk of code in terms of how it works. So here are the files. Here we have a particle, which is the actual particle itself. We have an emitter, which is the thing controlling how the particles get to be created. We have a bunch of settings, which will give you the settings whereby you can simulate the smoke or the explosion or the particle effects. And these three things here, they really are what we mean by the particle system. The rest of the stuff, here we have a activity, and we have a fragment file for this one here. So I mean, we'll look at these ones here first of all. That gives you the setup. Particle world also ties into these three things, and vector2, we'll come back to that in a second. So the fragment, if you like, is the one that contains a thing that we're drawing to. It contains, or notionally, our game world. Now, at the minute, our game world only contains a single particle system. So it's called particle world, but it's just where the particle emitter actually lives. Because we can touch on the screen, either as I was sort of moving about, showing the position, or dragging the mouse around, and it's this render surface that we get our touch events. We are recording or remembering the last touch location and passing this into the world, which will pass it into the emitter. Beyond this, when we're creating the view, we're creating a new world. We're setting up a render surface, adding in that touch listener, so that any touch events, doesn't matter, it's not multi-touch, we just store the last touch event, and we store that location. Resume, pause, usual stuff. There we have a actual render surface itself. It's a runnable component. So this we've seen before. When we run it, it will call down here, or update our world, and then we'll draw the world to the screen. So this is similar to what we had before. Particle world then, so this is going down to the next level. Notice this is our game world, but in this case it's just a world that contains a simple particle system. So what do we have here? We have a few things. We actually have the emitter. Now the emitter is responsible for managing its own collection of particles, so it contains the particles that it emits, if you like. So the world simply contains an emitter. We have a bunch of settings, so current particle system, and the emitter uses these settings to control, well, how the particles get to be emitted, under what properties. And initially we're starting off with the explosion effect. So we'll have a look at this class in a bit. You'll see that there's 3 built-in default sets of settings, though you can modify them as you see fit to produce new effects. We have that very simple, again, button doesn't do it, it's an insult to a button, that very simple touch area at the top of the screen. Whenever I clicked on it, it sort of transitioned from one demo to the next. Here we're creating then our world, passing in the context, so it loads in some bitmaps. So it says, okay, let's, actually I've done that twice, so let's set our current particle system to be explosions. We create a new emitter, pass in the context because it loads in a bitmap, and we say, okay, here's the particular one we want you to use. Now, it would be better to actually pass in this one here to it, but you get the idea. So we're passing in the types of settings that we want to use for it. There we try then to load in the arrow and set it up for our sort of next button. When we're drawing, or we're updating out rather, we only update we have here 2 components. First one is check to see have we clicked on our next particle system button. If we have, then we are going to set up for the next particle system. If we, or irrespective of what we will always do within the update is go to our emitter and ask it to update itself. We're passing in the elapsed time, so the emitter needs to know how much time has passed to update the particles, give them new positions or whatnot. It also needs to know the last touch location on the screen. So for example, if it's an explosion emitter, we're creating the explosion at that last touch location. If it's the sort of dropping purple particles, we're using the last touch location as a way of working out where we're creating our new bunch of particles at. A little bit here for setting up the next particle system. It's all fairly routine stuff, just switches and goes on to, if we were on explosions, then okay, changing to that, then passing in set particle system explosions or particle or smoke, just alternating between the sets of them. For drawing it out, set the screen to black, ask the emitter to draw itself out, and then draw our button on top of that. So not much happens within that. So these 3, the demo, the activity, the fragment, and this world, these are just the setup for this here. The final bit we have, I mean, particles, this is a 2D game, they have an X and a Y location. So we're pulling in here our vector2 utility class. It's just simply as a way of bundling together an X and a Y value. So there we can set it, we can add values onto it if we're moving our particles. So we'll use vector2 within the class. Right, so let's have a look at the 3 important classes, our particle, the emitter, and then the settings file. We'll do a particle first of all. So these are the things that get to be created and have a lot of them displayed on the screen. Emitter, or each particle is actually quite straightforward. So a particle has a position, whereabouts it is in the screen, and we're saying that's a type of vector2. It has a velocity. If we think about those particles, they were moving. So we give it a velocity. It has an acceleration. Again, there is an accelerative force within these, so they can move about. They also have an orientation, which angle the images are pointing. Now,
these images, like of smoke clouds or so on, they're you know, sort of they're not obviously pointing in one direction, but because we want to have visual variety, we want them to change, to rotate, to move around. So we give them an orientation. We have an angular velocity, which is the speed with which they are rotating. They can be fast rotation, slow rotation, or no rotation at all.
Then we also have the scale. So this is a simple bitmap. Sometimes, for example, for smoke, we want it to increase in size as it gets older. The smoke sort of billows out. So there, when the scale value, we'll use that to determine the amount of scaling that we apply to the bitmap. And the scale growth is how the scale changes. So maybe, let's say initially for doing the smoke, we'll draw them out with some random sizes. Maybe, 0.5 to 0.7 is going to be the set of scale values, sometimes big, sometimes small, but a little bit smaller than normal. Scale growth would be a positive value here, again, within a certain random range, so that over time, each of our smoke particles, as they move up, they would also increase in size, they'll billow out. Alongside that, when we get into drawing, we also have the idea of fading. I'll talk about drawing, or about fading when we look at the draw phase, but generally speaking, we fade our particles in, and we then fade them out. At the start of their lifespan, they're faded in. At the end of their lifespan, they're faded out. And this then ties into the notion that each particle, it lives for a certain period of time and then is discarded. And again, this is or you can control how long each particle lives for. So this is the lifespan of this particular particle, and then we have a indicator of, well, how long has this particle been in existence for? So a fairly simple, straightforward set of properties: position, velocity, acceleration. It moves, orientation, angular velocity. It rotates and has an orientation. It can be bigger and smaller and change its value, and it lives for a certain period of time. So particles are sort of simple moving entities. Now you'll notice there we don't have a bitmap reference within this, and again, for what we're using for displaying it, you'll see that we have that contained within the emitter. It's an arbitrary decision. If you did have something with different particles that wanted to be attached to their own bitmap or have a bitmap reference, then yes, you could embed it within this if you wanted to. But this implementation is not the case. Simple method for working out, is this particle still alive? So it works out time since birth compared to the lifespan itself. Now, if I scroll up and scroll down this here, what you won't find within the class are any constructors. So particles, because they are created and they die and we recycle them, we don't want to be calling a constructor and then calling a destructor to get rid of it. Rather, we're going to create a whole bunch of these things, and then we're going to reinitialize them or recycle them. So we have here an initialize method. And this is effectively doing the job of the constructor. Anytime I want to reuse this particular particle, I want to give it a set of values. So I will call the initialize method. And there I'm going to pass in a position, a velocity, an acceleration, orientation, angular velocity, all of the things that I need to initialize it. And we store the values here. Now, important, notice that what we are not doing here is, for example, this dot position is equal to position. So, for example, saving the one that was passed in, because these are objects. So effectively, this line here would say that the object that this points to is pointing to the same object here. We don't want to do that. What we want to do is to copy the contents of the position within this to the position that this particle has. So it's very important that we do that to avoid a potential a bug within the program. So there we're copying out the position, the velocity, the acceleration, orientation, all of the other stuff. So this stores the values for this particular particle. For update, and again, you notice that there's not a draw here. So in this case, each particle is not responsible for drawing itself. Rather, the emitter is going to be responsible for drawing a whole bunch of them. Update though, we update it, we have to pass in the amount of time since the last update. We use that delta time to update our velocity using the acceleration, the position using the velocity, the orientation using the angular velocity, and the scale using the scale growth. So just the values change. And finally, our time since birth, we increment that as well. So individually, a particle is very straightforward, doesn't do much. Let's have a look then at actually we'll do particle settings next of all and leave the emitter till last. So particle settings, looks reasonably long. All of this is a bunch of values. And we have here an enumerated type for the three built-in, if you like, default sets of values: smoke, explosion, and particle effect. And you can see here that we have public static particle settings smoke. So we have a static particle settings called smoke, which contains a whole bunch of numbers in essence. Another one for explosion is another whole bunch of numbers. I'll come back to those in a second. And particle, again, another whole bunch of numbers. So these numbers, these values that determine what and how a particle system behaves as opposed to an explosion system, as opposed to a smoke system. So let's have a look at some of these values. A few other enumerated types, just by way of rounding this out. One is the acceleration mode. Is either aligned or non-aligned. This is important, and this is about the acceleration of the particles relative to their velocity. If the acceleration is aligned, it means that it is accelerating or decelerating in the direction of travel. So things will carry on in a straight line from their point of creation, but will change their velocity along that straight line. So for example, if we think about an explosion effect, in an explosion effect, we want to give our particles a large initial velocity. They move out from the center point with a high velocity. But we want them to slow down as they move out in that particular direction. So there we want our acceleration to be aligned with the direction of travel. It just happens to have a negative value, so in fact it is a deceleration. So for the explosion then, they move out at high velocity, we then decelerate them in their movement of the direction. So effectively they all zoom out and they sort of slow down as the explosion gets further out. If it is non-aligned, it means that we will give them an initial velocity and we'll also give them an acceleration. And that acceleration can be in any old direction. We'll control the values if we want to. And it means then you can have particles that may sort of shoot out in one direction, then sort of change their direction of travel thereafter. And it can be good for things maybe where you're trying to sort of simulate sort of a windy effect or things being blown about within the wind. They may have an initial direction or scattering, but thereafter then they're subject to other accelerative forces that bring them in different directions. Emission mode is either burst or continuous. So for explosion, it's a burst mode. You create a bunch of them all at one point in time. For the other two effects, for smoke and for the particle effect, it's continuous. They're continually being created, a fixed number per second. Other properties we have here for a particular effect, the texture that we're using for it. So for example, we go up to particle settings. Here we're saying that we use what's known as particle PNG, just that simple purple one. Here we have our explosion PNG. And I can show you the different ones, just by way of having a look at it. So particle PNG is just our very simple purple dot. That's our ribbon from the previous one. Smoke. It's hard to see here, but basically it's a white surround. And explosion is actually quite a dull coloured explosion. The reason for that is because we will combine them using additive blending. So we will be adding multiple ones together. And if we have, say, 10 of these all drawn on top of one another, it will appear to be much brighter. As they separate out, then the colour will naturally decrease anyway. And that's kind of what we want to have happen. So we give the texture, we say whether or not for this particular particle effect, are we using additive blending? So for explosion effects, yes we are. We want to add them together additively. For the other effects, nope, we're just using normal. It would be false here, we're not using additive blending, it's just normal alpha blending. Other ones then, so emission mode if it's fixed or continuous in terms of how it goes out. We have, just one second. So here we have then our minimum maximum burst time, minimum maximum number of particles. So we can say then for this particular particle effect, how much time do we want to have between a burst? So is it every say half a second to 1 second we want a new explosion, or is it every 1 second to 2 seconds? So we get to control that. Minimum number of particles, maximum number of particles. So when we create, for example, an explosion, are we creating between, say, 40 and 60 explosions? Or if this is continuous, then how many are we creating each second? So we have a look, let's go to explosion then to see what the values of that were. So emission mode is burst. We're creating here an explosion, well, once a second, there's no variation within it. Each explosion will have between 50 to 60 different particles. So these are just the values. For our smoke effect, then it was, we had a burst one for this one here. Really should be continuous, I suppose. We were creating between 4 and 16 particles every half a second to 1 second. So again, just different in the values for that particular one. So that's minimum burst time, maximum burst time, and min and max number of particles. Acceleration mode then, whether or not it was aligned with the initial velocity, and if it isn't aligned, then we give here the angles. So these are angles in terms of, you can sort of have them accelerate in a certain direction. Now it could be from 0 to 360 degrees any old direction. It could be from minus 45 to plus 45 in terms of sort of a 90 degrees funnel. But you can specify here the direction in which things get to be accelerated, and also the speed or the strength of the acceleration. And again, this can be positive or negative between the minimum and maximum value. So we have a look at our, say, explosion effects. There we're saying it is an aligned acceleration. So it doesn't matter about the min or max because it's not being used. But the acceleration then is minus 750 to minus 760. So it's more or less in the same range, but it's a negative. So they will decelerate in the direction of travel. Gravity. So we have separate values for gravity. The reason we have a separate value for gravity alongside an acceleration is that gravity is a constant term that affects every single one, pulls them all in exactly the same direction. So gravity is one that can apply to all particles, but will bring them all in a certain direction with the same overall strength. Other values then, we give them our initial maximum speed, how fast they are moving, and again the direction that this particular velocity takes them in. So this is the, if you like, the direction of the velocity, this is the strength of the velocity, both combined give you overall velocity. Orientation then is also how we have the thing orientated, and again we can have them either completely random or sort of just slightly off center depending on what we want. Lifespan, again, we've got minimum max scale, minimum max scale growth, minimum max. For all of these, you can see, we have a minimum maximum value, and it's this randomness that helps give the particle system its particular characteristic, that we're generating a lot of these things, all slightly different than one another, and they happen to combine together in a way that's quite satisfactory. Massive constructor there, so when you set it up, you pass in all of the values. Effectively, all you do then is store the values. So, may look to be a lot to it, but all it is all of the parameters that the emitter is going to use. Nothing more than that. Right, emitter then. Let's finally get on to that. This is where all of the excitement happens. So inside the emitter, few things. We have a few static classes here. One's a random object, and then a few methods. The reason we have declared one as static is that because we want to create a lot of properties, random properties to assign to our particles, we're going to need a random object to do that. Now we could just create one with each instantiated emitter. That would be perfectly fine. Because I want to do a few static methods, just by way of simplicity, again, I just created one here on its own. We have a couple of methods then. Random between, if you give me a minimum and a maximum value, for example, any of the setting values where we had a minimum and maximum, I can then return a value from the minimum up until the maximum value. Similar one here for picking a random direction. Now, we were all dealing with angles in terms of our minimum and maximum. So these are minimum and maximum angles. And I'm outputting from this here a directional vector. So it's not an angle itself. It's going to, well, it's a vector that points in a particular angle. Because I mean, a vector is an object. Because I don't want to be creating unnecessary objects within this, I'm not returning a new vector from this. Rather, I say, if you pass me in a vector, I will then populate this vector with the direction. And it's just a way of avoiding creating one. So I initially pick a random angle, calling my random between method. This, similar to Android, we're working degrees here, even though most of management scheme programming you work in radians. I want to use my, to work out what angle that corresponds to. So I need to convert then my angle in degrees into radians. Having done that, I can then use the cosine and sine. It gives me a simple directional vector. And I set those two values, and that's what is output, effectively, from this method. So I've got a context. I use that for loading the bitmap. I've got the bitmap that this emitter uses. So here we're assuming that this emitter only manages a single particle effect. Okay, we can change it, but there's only one on the go at a point in time, where we have a single bitmap at a point in time. Now, particles have a position. We want to center the image on that particular position. So here we are storing the center point of this bitmap. So anytime we draw out the bitmap at a particle, we're going to center it. So the center of the image is located where the particle location is. Paint. We need to have a paint here because sometimes we'll be doing additive blending, sometimes normal alpha blending. We've got a time to burst, so if we do have a burst mode, then this will record how long until the next burst occurs. Last location, okay, where the last touch location was. These are more relevant things here. So these are particles. Now, as I've mentioned, the emitter, it manages the particles. And a particle is either going to be actively being used, so it's being used, it's appearing on the screen, it's evolving, or it's died and it's not currently being used. So I'm going to have a list here of free particles, ones that are available to be sort of recycled and reused. And particles will move between these different lists. So anything in active particles is active, it's visible, it's moving. Anything in free particles, it's in reserve, ready to be recycled and reused as need be. And the whole idea of this is to avoid object creation within this. Then finally, we remember the settings that we have for ourselves so that we can sort of create new particles as need be. Constructor then, passing the context, passing the set of particles, settings that we're using. We store these, we create our new linked lists. The reason we use a linked list as opposed to array list is that in all cases here, if we're for active particles, we're simply iterating through from start to end. Linked list is okay for that. But we will want to remove elements from it or add elements to it. The removal bit for a normal array list, that can be quite an expensive operation. So a linked list is just simply an easier way of being able to add and to remove particles from it. Initially, we create 100 particles, just create a new particle and add it into, I spelled particle right there, and add it into our list of free particles. So there they get to be added in. Configure then, the method configure basically looks at the settings and sets the thing up. We'll look at that in a wee second. Set particle settings then, so this is similar to constructor. It's where we've constructed our emitter, but we want to change the settings that we have. So similar to this one here, but we're only changing the settings. So what we do here, there's a few things. We want to remember the settings first of all. We might be sort of mid-active display at the minute. So we may have some particles on our active list, and we want to immediately decommission them and put them back onto our free particle list. So what we're doing there is we're getting an iterator for our active particles. We'll talk a little bit more about this form in a second. Iterating through, removing it, adding into our free particles. So basically, if there was something active when we change the particle settings, we get rid of it. And we then call our configure method again. So configure method, this is one that gets this emitter set up for a particular effect. What does that involve? It involves trying to load in the bitmap that the particle effect uses, working out where the center of the bitmap is, and then setting up or configuring our paint so that if we're using additive blending, then it is indeed additive blending is what we use through the paint component. And we're setting any units into picture true as well, just for additional visual impact. Okay, so that gives us all of our setup. Now, the other things within this here are effectively adding in particles, or adding in, for example, a new explosion effect, and then updating and drawing. So let's have a look, first of all, at adding in a new particle effect. We're going to reuse, so again, vector2s are objects, so we've got two, if you like, temporary variables here that we will reuse. So add particles is our method. We give the location, and we're also storing the last location, and you'll see that we will need this. For an explosion, we just create the explosion where the location was. But whenever we were doing the particle effect and dragging the mouse about the screen, the particles were created between the different settings. So in this, which one was it? This one here. So whenever I move the mouse across, we have particles being created more or less between the different points. So they're spread out. They're not being created all bunchy at the same point in space. So for me to do this here, I need to then have the last location and the current location, and I can string my particles out between those two different points. So if I'm adding them in, now, if it's bursty, then this will be only whenever I get to a burst location. If it's continuous, then I'm going to be calling this more or less continuously. I'm working out how many particles I'm adding in then, random between our minimum and our maximum. I'm setting up here depending on the emission mode. Now, if it is burst, then we're just creating them all at the location and there's no offset. If it is continuous, then I'm stretching them from the last location, and the offset will take me at the end of depending on number we are creating number of particles, it will take me through to the current location, so it strings them between the two. We have our for loop then, which will create our particles, goes through a number of different particles. We're not creating, we've got a reference here. If we have a free particle that's available, if we do have a free particle that's available, we'll remove it, and that's the one that we'll be using. If we don't have a free particle, so we're creating a new effect and our free particle list is empty, then we will create actually a new one. And when we discard it, we'll add it back into our free particle. So we'll add this, but we'll build up our collection. We initialize the particles. We're doing this for each particle. We're going to give it an initial set of values, and we add it into our active particles. The last bit at the bottom is where if we have, it's not burst, it's continuous, then we are moving the position at which we create the particle on by the offset. So this will stretch it out from the previous location to the current location. It stretches along that particular line. Initialize particle then is the next bit. So we're to call this for each particle. We want to give it an initial value. And we've got a few temporary direction, velocity, and acceleration, a few temporary values within this. And again, when we initialize a particle, we say, okay, here's the particle to initialize, and here's the position that we will be creating the particle at. This here then is very straightforward. So we're creating our random direction based on the settings from the particle settings. We're giving it a random speed, again, based on the settings. We are creating a velocity based on the direction and the speed, creating the lifespan for this, doing the orientation, angular velocity, scale growth. So these are all of the different values that a particle has, and the particle settings randomly determine the range within which they are created. A little bit down here about the acceleration mode, that if it is aligned, then we're going to be picking the magnitude of the acceleration, but we're basing that on the direction of travel that it currently has. If it is non-aligned, then we're picking a random direction, depending on the properties, for the acceleration and the magnitude, depending on the properties, and then setting it up in that particular direction. So it does sort of differ then. Having done those values, we then initialize the particle. So we call them the different properties, pass it in, that sets up the particle overall. Last thing then is update and draw. So if we're updating our particle system, we're passing in how much time has elapsed and any sort of touch locations that we have. This is the current touch location. So the first thing to do as part of update is actually check to see, do we need to add in a new bunch of particles? So if time to burst is greater than 0, so no, we've still got a bit of time, then we're decrementing that by the elapsed time. If we have triggered it, then we say, okay, let's create a new a burst time. So again, between min and max, we'll reset our burst time 1. We'll add in a bunch of particles at a current location and the last location. And then finally at the end, we remember the last location in which we created these particles. So this gives us an opportunity to string them out if we're doing it continuously. So once that's finished, then we may or we may not have created particles depending on the burst time. What we do want to do, irrespective, is then to update all of the active particles that we have. Now this gives us a bit of a dilemma here because we're updating particles. We're going to be iterating over our list of active particles, and if we find a particle that has expired, its lifetime is finished, we want to remove it out from that particular list. So we are, if you like, doing two things. We're iterating over a list and we're also modifying that list at the same time. You need to be slightly cautious doing that if you're iterating and modifying, that the iterator you're using is sensitive and takes into account any modifications that you make. Now, there's a safe way of doing it, and that is actually using a specific iterator. So for an array list, for a linked list, we can go to it and we can ask it to give us an iterator. It'll be starting at the beginning and it'll iterate through to the end of that particular collection. So I get my iterator here to a particle. Whilst there's still something I can iterate to, so at the start this will be the first element, I say, okay, well give me this next element. So this will begin at the beginning and then we'll just iterate through. Gravity, we set affects everything equally. So there we update the particle so that gravity makes a difference into its velocity. We call the particle's own update, and it then applies its acceleration, velocity, angular velocity, things like that. Now, we're updating how long the particle's been alive for. If the particle isn't now alive, it's extended its lifespan, then we want to remove it from the list of active particles. So we can go to our iterator and we can say, can you remove yourself from the thing you're iterating over? And it removes it safely. Now we don't want to throw it away, rather we then say, okay, now we've removed it from the list of active particles, we want to add it into our list of free particles, so we retain it, so we add the thing in. That's more or less it. For drawing it out, we're going to use a temporary matrix here because we're going to be rotating and scaling and things like that. For drawing it out, this is a crude draw mechanism. It won't scale up to a large number of particles, but it does the job okay here. We iterate through all of our active particles, the ones that are currently involved. This is the bit here well, it's an assumption about how things change, but it's okay for these types of particle system. We're assuming here that when a new particle is created, it fades in, and as it approaches the end of its lifespan, it fades out. So there's a bit here about normalizing it, so that it's only 100% alpha right at the middle of its lifespan and then fades out to 0 at the beginning and the end. We set up the paint alpha value depending upon the lifespan of this particle. Get ready for a matrix, so reset to identity, apply the scaling, apply the rotation, there's no orbit, then apply the translation, and then draw the thing out finally at the end. So not a huge amount to it, effectively just a bunch of particles that we are giving values to based on some settings, and then drawing them out en masse to the screen. So I mean, it works reasonably well, is quite extensible, quite flexible for what you can add it into.